All right, before we do this next example, I want to point something out. When you're doing a surface area problem or an arc length problem, you can use either form of ds that you want. You can either do it with this one where it's in terms of x, or this one in terms of y. Now, this is unlike the volume problems. With the volume problems, once you decided on a method, that determined whether you had to do it with respect to x or with respect to y. With these, you can choose. And sometimes the setup is easier one way, sometimes the setup is equally easy, but the integral you get is easier to do with one than the other. So what I want to do on this example is I want to set this up both ways, and we'll compare the integrals. Maybe we'll only do one of them, maybe we'll do both. But let's get started. So we've got the curve y equals cube root of x. Now that looks like this. If we take that and rotate it around the y-axis, we'll get this sort of shape. And let's look at that on the computer. Let's see. If I take this and I put in y equals x to the 1/3, and I graph that from 0 to 8. Let's see. And rotate it. Yep. I'm rotating around the x-axis. If we rotate it around the y-axis, we get this. And so this thing, if you look at it, we've got a surface here. Let me turn the number of. So we've got this surface. It's kind of hard to see, but it's it goes in the middle. It's shaped maybe kind of like one of those things that coins roll around in the mall before they spiral down the middle. So anyway, that's what we're looking at. So let's draw. My drawing here won't be as good as the computer's, but I'm going to just draw a band on this. That's a pretty terrible drawing. But we need to work out ds, and we know that the volume is going to be 2 pi integral of radius times ds. First up, let's do it with respect to x. So I've got y equals cube root of x. So dy dx then is 1/3 x to the minus 2/3. I'm going to rewrite that as 1 over 3 x to the 2/3. And so my ds, a lot of the time when I do this, I just sort of write it on here. This is squared. So what's that equal to? That's 1 on top. On the bottom, you've got 9. And when you square x to the 2/3, remember, whenever you square something, you double the exponent. So this becomes 9x to the 4/3. So our ds is going to be square root of 1 plus 1 over 9x to the 4/3 dx. And so our surface area is going to be the integral of, let's see, what's the radius in this case? Actually, let me write that down before I do the surface area. If we come back up here and look at it, the radius goes from here out to there. And if we're looking at this in terms of x, the radius is just x. So we get 2 pi x times the square root of 1 plus 1 over 9x to the 4/3 dx. And our endpoints go from the middle out to here, or out to here. So from x equals 0 to x equals 8. And that is our surface area integral. Now, if I wanted to actually work this thing out, we'd have to simplify what's going on inside the radical and work from there. We might have to do a trig sub or something like that. I'm not really sure. But let's set it up using dy and see what we get. So I'm going to come up here and I'm just going to cut the page in half. If we do this using dy, then first up we need to solve the original equation up here for x. If y equals x to the 1, or the cube root of x, cube both sides, you get y cubed equals x. Okay, so now we'll take the derivative of this. I'm actually gonna rewrite it as x equals y cubed. So if we take the derivative of this with respect to y, we get dx dy is equal to 3y squared. And then if we square that, we get 9y to the 4th. And so our ds in this case is square root of 1 plus 9y to the 4th dy. Okay, what's our radius? Well, as before, the radius is still x. But we need to put that in terms of y. So if the radius is x, x is equal to y cubed. So the surface area is going to be the integral, 2 pi integral of radius times ds. And since we're doing this with respect to y, we're still going from, remember this curve went from 0 to 8. So we still need to go from one end of the curve to the other, but we need the y coordinates for it. And the y coordinates here are 0 and cube root of 8 is 2. So both of these are correct. I'll put a blue box around them. This gives us the surface area, and this gives us the surface area. And of the two, this one is by far the nicer integral to deal with, because we can just do a quick u sub. So let's do that one. I'll still just do it in black. If we let u equal 1 plus 9y to the 4th, du is going to be 9 times 4 is 36y cubed dy. I'm going to move this over. So I get that for my u substitution. And for my top number, the u that I get there is 1 plus 9 times 2 to the 4th. So what is that? I think that's 145. Let me double check it. 9 times 16 is 144. So yeah, 145. And on the bottom, the number we get is u equals 1 plus 9 times 0 to the 4th. Well, that one's easy. It's just 1. So our substitution stuff over there, we've got 2 pi integral from 1 to 145 of, let's see, the radical becomes square root of u. Radical becomes square root of u. Y cubed dy becomes du over 36. I'm going to put the du there and the 36 out front. So I get pi over 18. When I integrate the u, I get u to the 3/2 with the 2/3 on the front from 1 to 145. So let's see, the 2 and the 19 cancel, or no, the 2 and the 18 cancel, give us a 9, so that's pi over 27. Yeah, pi over 27, u to the 3/2 from 1 to 145. So you get pi over 27 times 145 to the 3/2 minus 1. It's 1 to the 3/2, but that's just 1. And that's our final answer. Let's see what this is numerically. If I do 145 to the 1.5 power get this number minus 1 times pi over 27. This gives me 203.04. So we've got an exact answer and we've got an approximation for this surface area. Okay, now here's what I want to do. Let's use Desmos to, we're done with the problem, but I want to go back and just verify that this integral here and this integral here give us the same answer. So let's pull up Desmos and look at it. All right. First up, let's put our integral in that we just did. 2 pi integral from 0 to 2 of y cubed times the square root of 1 plus 9y to the 4th dy. And sure enough, it gives us the same number that the calculator gave us. I guess it would be helpful if I put the integral we're looking at up here. All right, so that integral gives us the same answer we got. Let's put the other one in now. This other integral, 2 pi integral from 0 to 8 of x times square root of 1 plus 1 over 9x to the 4/3 dx. And sure enough, it gives us the same thing. So on a lot of these types of problems, you can work them out with respect to x or with respect to y. But a lot of the time, one is going to give you a much nicer integral than the other.